All right, for our 6-8 notes, we're looking at applications of the Pythagorean theorem. And that is an important part to know that we are talking about Pythagorean theorem. What kind of triangle does the Pythagorean theorem work on? A right triangle, and a right triangle only. So when I'm doing word problems, guys, don't get hung up on the fact that they're word problems. Okay, I promise you, you will be successful if you practice these. Okay, but in word problems, what you need to notice is that if there has to be an application of the Pythagorean theorem, there has to be a right triangle somewhere in the picture. Okay, so sometimes I even just start reading without reading the question. I just start by drawing a right triangle. Okay, now you do want to, without me reading this specific problem, you do want to think about, if you were drawing just a random right triangle, I'm going to erase this in a minute, okay, where things would make sense. So for instance, if somebody asks you about a runway, the ground, the floor, which of these three sides should be the ground, a runway, or the floor? Well, I hope you would be thinking they would be down here at the bottom. Okay? If somebody's asking you about a person who's standing, a building, which we all assume that stands straight up and down, then I hope you would be picking the side that is vertical. Okay? So this would be somebody standing, or a building, a tower, anything like that. And then if somebody was telling you, hey, we've got like a ladder leaning on the edge of a building, okay, or leaning up the side of a building, well, then I hope it would make sense that this would be the leaning ladder. Okay, so it's just about making sense of where things go in the picture, okay, with the right triangle. So let's get into it. Okay, let's go ahead and start with this. So for this first one, I'll just go ahead and draw a random right triangle and see if I can get this to fit. So Bill is standing 20 feet from a 40-foot tall telephone pole. There's a bird sitting on top of the pole, and how far is Bill from the bird? Okay, so let's just start going through and making things make sense. So the pole should be the thing that's standing up and down, and it's 40 feet tall. So I'll go ahead and label the pole where it makes sense to be 40 feet. Bill, oh, well, let's go this way. There's a bird sitting on top of the pole, right? Okay, so I mean, you guys can get creative. You can draw your little bird, okay, whatever. But what you got to realize is he's really just going to be considered a point right there. Okay, so there's the bird. It says Bill is standing 20 feet from the pole. Okay, so from the bottom of the pole, Bill is standing out here 20 feet. All right, so here's Bill. But you're going to pretend again that he doesn't like have any height. You're just going to pretend he's that point, if you will. And that distance from there to the pole is 20 feet, so label that. And then it says, how far is Bill from the bird? For these word problems, we're being very literal. So straight from Bill to the bird would be that you don't know, so we'll call that X. There's the required picture that I expect to see from you, so I need to see a picture for every single one of these, and then I'll be able to follow your work. Okay? Following the kind of order of what we've given you, that you're always supposed to be able to reduce and then do triples and then Pythagorean theorem, we're doing the same thing here. So I'm looking at 20 and 40. I can reduce by 20. And if I reduce, I would get 1 and 2. Those don't reduce any further. Okay, so I'll go ahead and ask myself, is there a triple? And you've got the 5 memorized that we expect you to have memorized. Okay, you should notice that 1 and 2 are not a triple. So I'll do Pythagorean theorem with these smaller numbers. 1 squared plus 2 squared equals x squared. So fill in our numbers. 1 plus 4 equals x squared. That means x squared equals 5. So when I take the square root of both sides, I'll get x equals root 5. Okay. Root 5 does not break down any further. And remember, that's your red x. So I need to multiply that by 20. Since I divided by 20 at the start, I need to multiply by 20 so that I can get the purple x, the one that's in the picture, which would be 20 root 5. Now you'll notice I'm not boxing it right away because these are word problems. Word problems need to make sense. Their answers need to make sense. Okay? I highly doubt when you're just out with your friends and you're saying like, how far away is this person or something, I highly doubt that if you were doing a measurement, you would tell me 20 root 5 feet. Okay? So this is where, this is the only place in the chapter when you're doing word problems. Sorry, I got interrupted. So the only time in this chapter that you might have a decimal, if it's where it makes sense, is when we do word problems. Okay? Otherwise, stick with the roots. So I should see 20 root 5 in your answer, okay, in your work. And then you'll go ahead and say, oh yeah, if we were talking measurements or something like that, maybe miles, then we would be talking about a decimal. So I want you to always go to the nearest hundredth. That's 2 places after the decimal point. And then word problems also always need units. Okay, like at the end, is it 2 boys, 2 girls, 2 yes votes, 2 no votes, 2 tacos? What is it? Okay, what are your units? So here we go. If you'll get on your calculator, that's why you got to have your own so that you know how to run it. Do the square root of 5 and then times 20. And if you're having any problems running your calculator, that's other questions to also ask. So make sure you do that. And then round 1 time and 1 time only, you should get exactly this. Okay, so if you're having problems rounding, ask for that also. X would equal 44.72. And looking at the picture, they were both feet, so it's going to be 44.72 feet. You need to be able to have that exact same answer as me. Okay? All right, the next one. Again, I'm not reading it yet, but I'm just purposely drawing a right triangle that looks like that. And now I'll read through it. So I've got a 25-foot ladder leaning against a wall. The top of the ladder reaches 24 feet up the wall. How far is the bottom of the ladder from the wall? Okay, so the wall is the vertical, right? We said the ladder would be leaning, so the 25-foot ladder leaning. All right, so this is the ladder. So we'll put 25 feet here. The wall is the vertical wall, right? It reaches 24 feet up the wall, so this is 24 feet. And then how far is the bottom of the ladder? That would be here. From the wall, which is over here. All right, that's my X. In order, you always reduce, check triples, and then Pythagorean theorem. So 25 and 24 do not reduce. Next question should be, are they a triple? Are they? And hopefully you're telling me they are. So here's how you show your work. You tell me the triple. They're always in order, smallest to largest, spaced by dashes. So you're telling me the triple is 724.25, which means you automatically know X equals 7. I did not reduce by anything. I don't have anything to undo. I'm already to the purple X if you're doing the color coding stuff. I just need a unit, which is feet, and that right there will get you full credit. Okay. Now, on this one, we'll call these direction problems, okay? So in the direction problems, guys, I noticed this one says, you know, Jill's walking, I don't care if you want to call that meters or miles or whatever, but she's walking 80 meters south and then 40 meters west and then 20 meters north. How far is she from where she started? So we get a lot of these problems with how far from where we started. So the first thing is understanding that eventually you might have like 10 different directions from me, okay? Now you know that everything's supposed to be related to a right triangle. So in starting this, and I'm just making this up, let's say this is our starting point, and somebody walks this direction, this far, and then this far, back here, over here, up here, this way, so on and so forth, and now all of a sudden they're saying, okay, how far are they from their starting point? And Miss Barber's told you it has to be Pythagorean theorem and there has to be a right triangle. I don't know about you, but I don't see any right triangles in that picture. Okay, so our first thing we're going to do is focus on how to kind of organize ourselves, okay, to be able to get a right triangle. And so we will do that first. We also probably need to review with you directions, okay, however you have these memorized. So north and south work against each other, they're opposite, and west and east work opposite of each other, okay. I just happen to know where north and south are, and I just think of west and east as spelling the word we, okay, across that. I've heard other people say, like, never eat soggy waffles as you're kind of going around it clockwise. Whatever you need to do to have that memorized. But the other big important thing to recognize about directions is the following. How does the north-south line meet the west-east line? And I hope you're going to tell me at a right angle, right? You'd have 4 right angles in there all the way around. That's the key, right? I need that right angle to make a right triangle. So here's what I do. You'll see me do this every time. I just make myself a list of north, south, west, and east. And I just gather all of the numbers. So look at the writing. It says we go 80... I don't care about the units since they're all the same, but I go 80 south, so I'll put that in the south column. And then I go 40 west, I'll put that in the west column. And then I go 20 north, I'll put that in the north column. And it didn't say anything about east, so this is 0. Now if I had another one that said like another 10 west, I would add the total for west and say that the total traveled was 50 west. Okay? All right, now since these work opposite of each other, right, north and south, like if I go 20 paces north, but then I turn around and go back 80 paces south, how far am I from where I started? Well, all you have to do is do the subtraction between those two. So if you do 80 minus 20, you're really a net 60 south because that was the bigger number from where you started. And likewise, west and east we said work against each other. So again, you'll just take the bigger number minus the smaller number and say you've got a net difference of 40 west because that was the bigger number from where you started. Okay. And again, that visual, guys, for that top one is if you had gone like what we just said. If you went 80 south, but then you turned right back around and you came back 20 north, well, then you're this distance of 80 minus 20. You're 60 south of where you actually started. Okay? That's the visual of what's happening there. So you'll always see me make that list. You'll always see me make that distinction. And now, guys, I am just going to plan ahead and say, all right, these are my 2 directions. Those are my 2 sides to the right triangle. And I know that south and west meet each other at a right angle. So thinking ahead, in my mind, I say, okay, I've got a starting point, and I'm going to go south, which is down on the paper. And then I'm going to turn and go west, which is left on the paper. Okay, so I kind of plan ahead so that I don't draw it off my piece of paper. So I can make my starting point here. I'll go down 60 meters south. Okay, because that's what this is showing me over here. And then I'm going to turn and go 40 meters west. I know that creates a right angle. And then they are asking me how far is she from where she started. We're talking literal, like straight from here to there. That's your unknown, so that's your x. Okay, so there's the picture that you need to be able to come up with for all of the direction problems. Okay, and then of course you know how to solve it based on what we've been doing, right? So we're always reducing first. 40 and 60 are divisible by 20. So that'll give me 2 and 3. Next thing I'll ask myself, since 2 and 3 don't reduce any further, is is there a triple with 2 and 3 as the legs? And there's not. So I'll use those smaller numbers with the Pythagorean theorem. 2 squared plus 3 squared equals x squared, since x is the hypotenuse. Get your numbers in there. 4 plus 9 equals x squared. Therefore, x squared equals 13. That means x would be the square root of 13, which does not break down any further. I have to undo what I did at the start. I don't want the red x, I want the purple one. So I need to multiply by 20 since I divided by 20 at the start, to get a final exact answer of 20 root 13 meters. However, Ms. Barber said in this chapter, our answers need to make sense for word problems. So when we're talking distances, we don't say, hey, I drove 20 root 13 miles today. Okay, we just don't do it. We do decimals. And so you're going to go ahead and, again, type in the square root of 13 in your calculator, times 20, push equals. Again, calculators work differently. Some of you can just type 20 root 13 and push equals one time. And then you're going to round to the nearest hundredth. So 2 places. You need to be able to get exactly 72.11 m. Okay, meters, miles, whatever you thought it was. Okay? So, you'll be successful at this again, guys, if you just practice it. Go ahead and make sure that you draw a picture for every single one of them. Okay, and then continue practicing your reducing triples and Pythagorean theorem.